Okay, recording.
Okay, so for a second example, more specialized to water quality, if we have a creek that has 10 milligrams of sediment for every 1 liter of water, so 10 milligrams per liter is a number we might expect to see, and we have we'll keep it simple, meter cubed, so that's a volume, per second of flow. So we'll talk more about discharge next week, but this is a volume per time, so a discharge in the stream. So we've got a concentration of sediment and a discharge in the stream, and if we want to get to a load for that, which is a mass per amount of time, which is how we think about watershed management, we might want to get to kilograms per year, and this is thinking about total maximum daily loads, or the amount of pollution that a water body can carry without becoming impaired. We often talk about loads, and units for a load might be something like kilograms per year. It's a mass per time typically. So let's walk through this example. So we started out, we said we had 10 milligrams of sediment for every 1 liter of water. And we know that our flow there, we said, was 1 meter cubed per 1 second, right? And we're trying to get to kilograms per year. So right now, we've got milligrams of sediment per meter cubed times meters cubed over liters per second. So it's not sensible units, but these two, meters cubed and liters, are both volumes, so they can cancel out, but we have to come up with an appropriate conversion factor. So since we have liters in the bottom, we need to have liters in the top to be able to cancel it out, and we need meters cubed in the bottom to be able to cancel it out. So 1 meter cubed is equal to 1,000 liters. 1 liter is a cubic decimeter, or a cube with 10 centimeters on a side. Convenient thing about the metric system. So now we can cancel meters cubed and liters, and now our units are milligrams of sediment per second. So we're now in a load, but we often think about loads in terms of kilograms per year. So we need to get there. So we can go to get from milligrams of sediment to kilograms of sediment. Again, we need milligrams on the bottom and kilograms on the top. For every 1 kilogram, there are 1 million milligrams. So that's just a conversion. This is equal to 1 right there. So we're just multiplying our equation here by 1, basically. And now our units, we can cancel milligrams, and now our units are kilograms per second. And now we need to get from seconds to years. And so you could do this in one step if you wanted to, or we could do it piecewise. And so we've got seconds on the bottom, we need seconds on the top, and we'll go to minutes. So in every 1 minute there's 60 seconds. Then we need to go from minutes to hours, and for every 1 hour there's 60 minutes. And we want to go then so we can cancel the minutes because it's in the top and the bottom. We can cancel the seconds because it's in the top and the bottom. Now we're at kilograms per hour. To go from hours to days, we need hours up top and days on the bottom. So for every 1 day, there's 24 hours. And I ran out of room here, so I'm going to come down. And now I can cancel hours in the top and bottom, and now I'm at kilograms per day. So I need day in the top and year in the bottom. For every 1 year, there's 365 days. Now I can cancel day in the bottom with day in the top, and my units are kilograms of sediment per year now. So this equals, so my units are kilograms per year. And to do the math here, I multiply 10 by 1,000 by 60 by 60 by 24 by 365, and then I divide by everything that's in the bottom, so by 1 million. And if I do the math on that, then I get 315,000 360 kilograms per year. So this, by keeping track of my units, I start out with what I'm given, and then I use conversion factors to get to the units I want. This process is dimension analysis, and what I've walked through here is what we have set up parallel in the Excel spreadsheet so that you can quickly modify numbers and think about different loads for your homework this week.